Oregon's second leading cause of climate pollution is our homes and buildings, but they're also our first line of defense against climate harms like extreme heat and wildfire smoke. That's why we're taking legislators on a tour of resilient, efficient buildings around Oregon. We're going to show them the technologies and techniques that will make our buildings more efficient and more climate resilient. Right now, we're at the Viewfinder in Tigard, which is an affordable housing, multifamily apartment building that performs better than your average building. It's got solar on the roof, it's nice and tight so the wildfire smoke can't get inside.
If we're talking about being sustainable, building location and orientation are very important. So this is our south-facing site, and it actually was a really interesting opportunity to orient the building to create a shaded courtyard that is north-facing so that the residents have an outdoor amenity space to use as well.
This building has a tight envelope. All that means is quality doors, windows, and insulation that keeps the comfortable air in and the air pollution out.
This is one of our residential units. For heating and cooling, we are using ductless mini splits. We usually locate them in the main living space. We are 100% LED light fixtures, and those light fixtures are all ENERGY STAR rated. From a plumbing standpoint, all of the fixtures from sinks to toilets are all low flow, and our appliances, they are all ENERGY STAR rated as well.
This school building was built smart from the start. That means folks inside are comfortable, it's energy efficient, which saves on bills. We can raise the standard in Oregon to make sure that all buildings are built to this kind of standard.
We created 5 career and technical education pathways, all centered around the idea of holistic, community-centered sustainability. In large part inspired by the fact that this is a net zero building. We produce more power here than what we use.
There's no electric lights on in this space. This project is 100% electric, right? There's no gas, there's no combustion, which could be harmful for indoor air quality for the local community.
We've got this beautiful garden space that our students cultivate and care for and run their own community-supported agriculture business. We've got an awesome manufacturing program.
This school's roof is covered in solar panels, which means they make more energy during the year than they even use. Buildings that create their own power are great for an emergency. People could come for refuge. We're here at Mamuk-Tokati, which is an affordable housing complex for folks here in Northeast Portland. This building saves in 2 ways. It's super efficient, which means the folks who live here pay lower utility bills, but also in the construction, because it's all electric, no gas pipelines were put in this building, which saves money, as well as its super efficiency means smaller heating and cooling equipment, which also cuts costs.
Low-income Oregonians and Black, Indigenous, and communities of color are forced to live disproportionately close to pollution sources and in homes that waste energy and don't protect against outside harms. Let's all remember that the technology here is to serve people.
Mamuk-Tokati means to make beautiful in Shinnequa. We have a strong building envelope, efficient windows, highly insulated. All the units have what are called ERVs, energy recovery ventilation systems. These are heat pump hot water heaters. They're highly efficient. There's a lot of heat coming into this room from all of the other systems that are here. They use that heat to heat the hot water, and then they reject cool air. This is a technology that's allowing this building to be an all-electric building versus having gas.
Welcome to Kellogg Middle School today. I'm the principal, Richard Smith. We're happy to show off this beautiful building we have.
The school is a LEED Gold certified building, and it's designed to be net zero energy ready. This room is a radiant heat floor system, which is very energy efficient. And then we have a displacement ventilation system, which you see up above, and that displacement air just drops at a natural rate. It's just a lot of air that comes into the room, and that's also very energy efficient.
We wanted to push this a little further in terms of energy efficiency. We found the additional premium was pretty low, and it balanced against kind of the longer term cost savings for operations. Really made a lot of sense.
The solar array you're looking at was what was required to meet the 1.5% for solar standard in the state of Oregon. The solar on top of this building would get the building down to energy use of 0. This school site was previously a school site, and so we went through a very detailed process of deconstructing that building so that we contributed as little to the landfill as possible. You will see in the building here some reused materials, but what's really exciting is that by diverting from the landfill and reusing, we only contributed 1% of the demolition to landfill. That is the equivalent of 137 747s that were diverted to one school bus that went into the landfill. Yeah, that's worth an ooh and an ah.